Good day class. So, welcome sa ating subject, Fundamentals of Deformable Bodies, which is also known as Strength of Materials. So, in taking this this subject, you should have a background in your statics of rigid bodies. So, lahat ng napag-aaralan nyo sa statics, you will be i-apply nyo dito sa ating subject, which is the strength of materials. Okay? So, you review yung statics ninyo and mas madali yung masosolve yung mga problems natin sa ating dito sa ating strength of materials. So, before we go sa ating problem solving, so yung module 1 natin is about stress. So, I hope and I believe na that you have gone through your module, you have read it, and you have watched also the videos regarding sa introduction natin ng stresses. So, simply, meron lang namang tatlong nabanggit na kind of stress doon sa ating module 1. So, that will be the normal stress, shearing stress, and the bearing stress. So, kapag short recap lang, so for normal stress, yung contact area natin is yung force is perpendicular doon sa ating contact area. Okay? And for the shearing stress, that is sliding. So, sliding force. So, yung direction ng force natin is perpendicular dun sa contact area. Okay? And for the bearing stress, so kapag bearing, two bodies are pressing against each other. Okay? And kung saan yung na-pressure, yun yung magiging contact area natin. Okay? So, simply kapag bearing stress, example niyan is yung footing natin, no? Yung footing against dun sa soil. So, nagkakaroon ng pressure. So, that is considered bearing stress. And yung mga lap connection natin, yung lump joint natin ng riveted connection. So, yung nagkakaroon ng stress yung sa may rivet natin and yung side ng hole natin. So, they press against each other. Okay? So, let's go ngayon sa ating solving problems. So, first is yung sample problem 1. So, the bar ABCD in figure A consists of 3 cylindrical steel segments with different lengths and cross-sectional areas. So, actual loads are applied as shown. Calculate the normal stress in each segment. Okay? So, sabi niya dito, normal stress. So, ibig sabihin, yung force over area natin. So, yung area natin is perpendicular sa ating force. Okay? So, first is kunin muna natin yung mga force along dun sa ating mga segments. So, for segment AB, BC, and CD. So, we have 3 forces na kailangan. Okay? So, for segment AB, so, kailangan natin i-section siya dito sa along 1. So, kapag sinection natin yan, i-isolate natin. Okay? So, i-apply lang natin yung natutunan natin sa statics. So, summation of forces is equal to 0. Summation of forces along horizontal is equal to 0. So, kung 4,000 ito, papunta dun sa left. So, syempre, yung internal force natin along segment AB, so force AB will be also 4,000 pounds. So, simple lang. Apply lang natin yung napag-aralan natin sa statics. Okay? And for the segment BC naman, so kapag hahatiin natin yan, dito isi-section natin along 2. So, summation forces horizontal ulit tayo. So, ito yung magiging free body diagram niya. So, meron tayong 4,000 na nag-act sa AB and 9,000 na nag-act along dito sa ating BC or dito sa along point B natin. Okay? So, para makuha natin yung internal force BC, dito sa segment BC, so summation of forces, horizontal lang tayo dito. So, summation of forces horizontal is equal to 0. So, kapalan lang natin ng content. So, that will be negative 4,000. So, this is pounds plus 9,000 pounds. So, yung direction ng force BC natin, that will be going to the left. So, that will be negative force BC. So simplifying yung PBC natin, yung force BC natin is equal lang siya sa 9,000 minus 4,000 pounds. So that will be force BC is equal to 5,000 pounds. Okay? So madali lang. And dun sa force CD natin, so section ulit natin dito sa 3, sa gitna niyang C2D natin. So makuha natin yung internal force sa segment CD, that will be 7,000 pounds. Kasi 7,000 pounds din yung nag-act dito sa ating point D. So equilibrium lang i-apply natin dito. Okay? So meron na tayong point AB. So this is 4,000 pounds. Point BC, 5,000. And yung force CD natin along segment CD, that will be 7,000 pounds. So makukuha na natin yung normal stress in each segment. Okay? So sabi natin, stress is equal to force over area. So first is yung segment AB. So that will be force AB over yung area natin. So yung force AB natin, that will be equivalent to 4,000 pounds over ano yung area natin doon. That will be 1.2 square inch. Okay? So yung magiging unit natin will be PSI, or pounds per square inch. O pounds over a square inch. Okay? So yung stress along segment AB natin, that will be 3,333.33 PSI. Okay? And for the stress BC, that is equal to ano yung force BC natin, so that will be 5,000. So 5,000 pounds over area natin for segment BC, that is 1.8. So 1.8 inch squared. It will be equivalent to 2,777.78 PSI. Okay. And for the last segment, that will be stress along segment CD. So force natin will be 7,000 pounds over ano yung area natin, so that will be equal to 1.6. 7,000 over 1.6, so that will give us 4,375 PSI. Okay. So, yun yung magiging final answer natin. So, next problem na tayo. So, thrust problem. So, I believe and I know na dun sa statics you have learned how to solve yung thrust analysis natin, to solve for the reaction and solve for the member force, okay, ng ating thrust. So, yung application ng ating strength of materials is kukunin natin yung stress na nag-act sa ating mga member. So in sample problem number 2, sabi niya dito, for the thrust shown in figure A, calculate the normal stress in member AC and member BD. So the cross-sectional area of each member is 900 mm squared, okay, or millimeter or square millimeter. Okay. So first, para na makuha natin yung stress sa member AC. Okay. So ito yung kukunin na natin ng stress, member AC and member BD. Okay. So first, kailangan natin kunin yung reaction. So apply lang ulit yung static. So dapat masterin nyo yung pag-solve ng reaction and pagkuha ng mga member forces, no, dito sa ating thrust analysis. So by equilibrium, so para madali nating makukuha yung reaction, so that will be reviewin natin yung statics natin. So makukuha natin yung HY, so mag-summation of moment lang tayo dito sa ating point A. So class, wala tayong horizontal force, so automatic yung HX natin will be equal to 0. So solving for HY, so summation of moment lang tayo. along point A is equal to 0. So, clockwise, positive, okay? Is equal to 0, clockwise, positive. So, first na magro-rotate is itong 30 kN. So, that will be 30. So, positive siya, no? Kasi pag ganun yung papunta sa A, magro-rotate siya along A. So, times yung perpendicular distance. So, 4 panels at 4 meters. So, this will be 4 meters. Plus 70 times, so this will be 4. 4 times 3, that will be 12. Minus yung HY natin times 16. So, solving for HY, that is equal to 60 kilonewton. Okay? Then, for the AY natin, so sa summation forces, vertical lang tayo, no? So, summation forces vertical is equal to 0. That will be upward positive. So, that will be negative 30 minus 70 plus 60 plus AY is equal to 0. So, yung AY natin, is equal to 40 kilonewton. Okay, so nasolve na natin yung reaction. So, kunin natin yung force na nag-act along AC. Okay? Kapag nakuha na natin yung force, we can solve na yung stress using yung formula natin, force over area. So, first, kunin muna natin yung force ng AC and yung force ng BE. Okay? So, statics lang ito, class, no? Kapag nakuha na natin yung reaction, so pwede nating i-isolate. May method of joints tayo. So, remember yung method of joints sa statics. So, point A, so this will be yung FBD diagram. So, meron tayong AY, 40 kN. And yung slope nung AB natin, so assume lang natin na tension. Okay? So, kapag tension, away from the point. So, assume natin na tension muna siya, lahat. Kapag negative ang lumabas, so magiging compressive yun. So, solve natin yung point AC natin, ay yung force dito sa AC. So, apply lang natin yung mga equation natin. So, summation of forces, horizontal muna, or along X, that is be equal to 0. So, going to the right, positive. So, that will be PAC. So, positive. So, plus, so yung horizontal component ng force AV, so that will be, so kung yung slope natin is 3, 4, so yung hypotenuse natin dito will be 5. Okay? So, that will be 4 over 5 force AB. Okay? Is equal to 0. Yan. So, second, ito yung magiging first equation natin. And for the second equation natin, so that will be summation of forces vertical is equal to 0, upward positive. So, meron tayong AY, that is 40 kilonewton, plus yung vertical component ng force AB, so that will be 3 over 5 force AB is equal to 0. So, we can solve simultaneously, no? So, kunin natin. So, dito muna tayo. So, kapag kukunin natin yung AB, madali lang natin makukuha yung AB. So, that will be, shift solve lang or input nyo sa calculator nyo. So, that will be force AB is equal to, that will be negative 66.667. Okay? So, yung force AB, so, negative siya, kaya compression. So, ito, i-substitute lang natin doon sa first na equation natin. Okay? So, makukuha natin yung force AC. Okay? So, for solving for force AC, so that will be force AC plus 4 over 5 times negative 66 0.67 is equal to 0. Okay. So solving for AC, force AC now will be equal to 53.33 kilonewton. So positive siya, so means that will be tension. Okay? So meron na tayong force AC. Okay. And then for force BE, so ano yung BD pala? So yung kukunin pala natin dito is BD, not BE. So ito, force BD yung kukunin natin. So for force BD naman, so review nyo lang yung ating statics. So para makuha natin yung force BD, kailangan lang nating gawin is method of sections. Okay, so for the method of sections, pwede tayong maghati ng tatlo. Okay, yung sa section natin, yung dadaanan niya is tatlong member. Okay, so maximum lang yon. Then we can, paano natin makukuha yung force BD? So in getting the force BD, that will be summation moment at point E lang tayo. Okay, so makukuha natin yung force BD. So statics lang to, hindi pa to strength of materials. Okay, so parang nag-review lang tayo sa ating statics. So summation moment at E is equal to 0. So clockwise positive, no? So summation of moment at point E. So ano yung magmo-moment sa point E? So first, yung AY muna, dito muna. So that will be negative. Okay, that will be negative 40 times yung distance niya 8 meters. Okay. Plus yung 30 natin. So so positive pala to, no? So ang gawin na lang natin, sige, i-constant na lang natin, no, clockwise positive. So magiging positive to. It will be 40 times 8 and negative 30. So that will be, so parehas lang, depende sa inyo kung clockwise positive or negative or counterclockwise negative. Okay, so clockwise na lang natin para constant. So same din yung lalabas dyan, basta i-follow nyo lang yung mga sign kung ano yung dinicide nyong sign convention. Okay, so AY magro-rotate positive, and then yung 30 natin negative, so that will be minus 30. So 30 times 4, and then itong BE natin hindi na mag-rotate yan, no? So concurrent forces siya, at saka yung CE natin hindi na mag-rotate sa E. So ang mag-rotate na lang is yung force BD natin. So madali na natin makukuha yung force BD. So positive siya, so that will be plus force BD times 4 meters. Okay, perpendicular distance pala, so that will be 3 meters. Okay, is equal to 0. So force BD is equal to negative 66.67 kilonewton. Okay, so negative ibig sabihin compression siya. Okay, so we can write it as force BD is equal to 66.67 kilonewton. So this will be compression. Okay, so meron na tayong force BD and meron na tayong force AC. So yung question sa ating problem will be calculate the normal stress in AC and BD. So yung area natin, yung area ng cross-section ng ating truss is equal to 900 mm squared. Okay. So for solving, stress along member AC, so stress along member AC, normal stress, so that will be equal to force over area. So force ng AC over yung area ng AC natin. So pare-parehas yung cross-sectional area nila, which is 900 mm squared. Okay? So that will be 53.33 kilonewton over 900 mm squared. So that will be equal to stress AC natin will be equal to 59.3 kilonewton over mm squared, or this is equal also to mega pascal. Okay, so that will be so solving for stress AC, so this is equal to also to divide natin ng, so kilonewton siya, so kailangan nating i-times ng 1000 para lalabas yung newton. Okay, so that will be 53.33 times 10 raised to 3, so magiging newton na lang yan, divided by 900. So kailangan natin i-convert sa mm squared naman ito, so sa meter, square meter, so that will be 900. So kapag i-convert natin ito sa square meter, so i-divide nang natin yan ng so kapag i-convert natin yan, so if we will convert it, so that will be 900 mm squared. So ilang meter, ilang mm ang meron sa meter, so that will be 1000. So that will be 1000. So 1 meter. So kung naka-square yon, dapat square din natin yan. No? So ang lalabas dyan, that will be 900 times 10 raised to negative 6. So ito yung ilalagay natin doon. Okay? So para makuha natin yung tamang unit doon sa ating stress. Okay? So that will be times 10 raised to negative 6. So magiging unit na lang is square meter. So yung Newton square meter natin, that is equivalent also to megapascal. So yung magiging stress AC natin is equal to 59.3 Newton over square meter, or 59.3 megapascal. Okay? So this is in tension. Okay, so for the stress BD naman, okay, so for the stress, yung stress BD, so that will be equal to force BD and yung area natin BD. So same lang yung area natin na 900. So that will be, yung force natin will be 66. So that will be 66.67 kilonewton over 900 mm square. So same lang din yung gagawin natin dito. So that will be 66.67 times 10 raised to 3. So magiging newton na lang. And then, so same lang din, 900 times 10 raised to negative 6 square meter. So for stress BD, that will be equal to 74.1 megapascal. So this is in compression, no? So dahil thrust analysis tayo, kaya meron pa rin tayong compression or tension. Okay? So ito yung magiging sagot natin, no? So stress BD will be 74.1 megapascal and stress along member AC will be 59.3 megapascal. Okay? So next problem na tayo. So sample problem 3. So figure A shows a two-membered truss supporting a block of weight W. So the cross-sectional areas of the members are 800 square meter for AB and 400 square for AC. So determine the maximum safe value of W if the working stress are 100 megapascal for AB and 120 megapascal for AC. Okay. So sabi niya dito, determine the maximum safe value of W or yung weight natin na hindi dapat mag-exceed yung stress niya sa 110 for AB and 120 for AC. Okay? So first is kunin natin yung force na nag-act sa ating BC and CB. Okay? So parang mag-a-analyze din tayo dito, no? So yung magiging kunin natin yung force BA and force AC in terms of W. Okay? Kasi hindi nga given yung W natin, kukunin natin yung maximum na pwedeng value ng W na hindi mag-exceed dun sa ating stresses. Okay? Dun sa working stress natin. So first, let us solve force AB and AC in terms of W. So magkakaroon tayo ng free body diagram. Okay, so if we have a free body diagram dito. So meron tayong weight na nag-act dito sa, sige, mano-mano na lang natin na i-drawing. Okay. So meron tayong weight dito na nag-act. So W. And we have the force AC. So this will be for AC. And meron tayong force AB. And ito is 60 degrees. Okay. And this one is 40 degrees. Okay. So actually meron tayong three forces dito. And if you remember your statics, meron dun yung tinatawag na force triangle. Okay? So, other than summation of forces, x is equal to 0, and summation of forces y is equal to 0, we can solve yung force AC and force BC, IAC and AB in terms of W using yung ating equilibrium equations. Okay? And makukuha natin, no, yung value ng W. And other than, meron din tayong isa pang method, which is yung force triangle, okay, in solving yung AB and AC. So yung nandun sa module nyo class is ginamit niya yung equilibrium equations. Ngayon gagawin natin is yung force triangle, okay. So kapag force triangle, we can make these forces into triangle, okay. So meron tayong weight, force na pababa, okay, so that will be, ito yung magiging W natin. And kung makikita nyo, yung force natin dito will be AC, so we can rewrite it as like this one. So pataas siya, so pag ganun, no, so dito sa right side natin ilalagay, okay, yan. And we have the force AB. So, pwede tayong maglagay dito. So, magkakabuo tayo ng triangle. Okay, naintindihan? So, ito yung tinatawag na force triangle. So, ito magiging force AC, and this one will be force AB. Okay? So, using properties ng triangle, sine and cosine law, using sine law, pwede nating masolve yung PAC and PAB in terms of W. So, kung yun is 60 degrees, okay, so kapag diniretso natin to class, no, doon sa free body diagram natin, so I hope na naiintindihan nyo, nakikita ninyo. So, kapag diniretso natin to, so yung properties ng interior angles natin, kung 60 degrees ito, this will be also 60 degrees. Tama? So, ano yung matitira dito? So, 90 minus 30, so that will be 90 minus 60, so this will be 30 degrees. Okay? So ito, yung angle na binubuo ng force AC and yung W will be 30 degrees. Ayan. And then, ito naman, yung force AB natin, so yung angle niya dito is 40 degrees. So yung magiging angle niya dito along sa vertical, along sa y-axis, about y-axis, so 90 minus 40, so that will be, ito is magiging 50 degrees. Tama? So this is 50 degrees. Okay? So yung triangle natin, ang total angle is 180, di ba? So that will be, yung magiging angle natin dito, so that will be 180 minus 50 minus 30, so this will be 100, okay? So 100 degrees yan. So using sine law, we can solve the force AC and AB. Tama? So force AB muna tayo. So force AB, so using cosine law over sine. So ano yung opposite angle niya? So ito yung AB natin, opposite niya is 30 degrees. So sine 30 is equal to force yung W. So that will be W over, ano yung opposite angle niya? That will be sine 100. Okay? So solving for PAB in terms of W, so ang lalabas dyan, that will be sine 30 divided by sine 100. So, force AB will be 0.5077 W. Okay? And then, for force AC naman, force AC is equal to, so sine law over opposite niya angle, that will be sine 50 is equal to W, ganun ulit, W over sine 100. Therefore, yung force AC natin is equal to, so sine 50 over 100. So that will be 0.777 7 W. Okay? So, meron na tayong force AB in terms of W and force AC in terms of W. So, now we can get the normal stress in bar AB. So, first, dun sa bar AB naman, bar AB muna. So, sabi natin, stress is equal to force over area. So, for AB, so, para makuha yung force, that will be force is equal to stress times area. Tama po ba? So, para makuha natin, meron tayong force AB. So, force AB is equal to, so stress, ano yung working stress natin dito? Will be 100. For AB, that will be 110 mega Pascal. Okay? So, working stress nung AB times yung area din ng AB natin. Okay? So, for force AB natin, that will be 0.5 0.077 W is equal to, so stress A na working stress natin sa AB will be 110. So naka megapascal ito, class. So kapag megapascal, so ita times 10 raised to 6 natin para maging Newton over square meter. Okay? So parang magiging 110 times 10 raised to 6 over Newton over meter squared. Okay? Para maging Pascal siya. Times yung area natin, so that will be 800. So naka mm to, class, no? So 800 mm squared. So i-convert na lang natin ng square meter. So kayo nang mag-convert. So kapag kinonvert natin ng square meter, so that will be 800 times 10 raised to negative 6. Magiging meter na siya. Okay? So, square meter na siya. So, yung W natin, so solving for W, so that will be equal to 173.3 times 10 raised to 3 Newton. Okay? Or equal siya sa 173.3 kilo Newton. Okay? Tama? So, meron na tayong weight kapag yung stress ng AB ang ginamit natin. So, first, kunin naman natin yung sa AC. For AC, sabi natin, stress equal to force over area. So, that will be PAC is equal to working stress ng AC times area ng AC. So, that will be equal to 0.7779 W is equal to, so yung working stress natin will be 120. Tama? So 120 megapascal for AC, sabi niya rito. So that will be, so convert natin ng Newton over square meter. So 120. So megapascal, so that will be times 10 raised to 6. So magiging Newton over meter squared multiplied by the area. So yung area natin is 400. Tama? So 400 mm squared. So convert natin ng meter ulit. So that will be 400 times 10 raised to negative 6. So solving for W, yung W natin will be 61.7 times 10 is to 3 Newton, or we can write it as 61.7 kilonewton. So meron tayong dalawang value ng W. Okay? And yung question is determine the maximum safe value of W if the working stress are 110 megapascal for AB and 120 megapascal for AC. So yung maximum na safe is yung lesser na W dito. Yun yung magiging maximum. Kasi kapag yung 173 kilonewton ang magiging sagot natin, nag-exceed siya doon sa stress ng AC. Okay? Dahil sa kapag AC is 61.7 kilonewton lang. So yung maximum safe value is yung smaller, okay? Of the two values na nakuha natin na W. So yung magiging final answer natin, so that will be maximum safe. So maximum safe W is equal to 61.7 kilonewton. So this will be our final answer. Okay. So next problem. So problem number 4. So the rectangular wood panel is formed by gluing together two boards along the 30 degrees seam as shown in the figure. Determine the largest axial force P that can be carried safely by the panel if the working stress for wood is 1120 psi and the normal and shear stress in the glue are limited to 700 psi and 450 psi. So, sabi niya dito, meron tayong wood panel, okay? And ano yung maximum P that can be carried safely, okay? Meron tayong 3 na stress dito, no? Working stress. First is yung sa wood, that is 1120 psi. Second is yung normal dun sa glue. So, normal stress dun sa glue and shear stress dun sa glue. So that is 700 and 450 psi respectively. So ano yung maximum axial force, no, dito na pwede na hindi mag-i-exceed dito sa working stress na tatlo, no? So first na gagawin natin is kunin natin yung force sa stress ng wood and force dun sa stress ng glue sa normal and shear. And yung pinakamaliit doon, yung lesser doon sa tatlong makukuha natin na force is yun yung maximum or largest axial force that can be carried safely by the wood or yung panel natin. So first, meron tayong first case natin is yung working stress doon sa wood. Okay? So yung stress, normal stress dun sa wood, that will be equal to force over area. So working stress natin is 1120 psi is equal to, so yung force natin, so hinahanap natin yung force, so force natin, that will be over, yung magiging area natin will be 4 inch times 1 inch. So solving for P is equal to 4,480 pounds. Okay. So pounds per square inch yon. So magka-cancel yung square inch. So that will be pounds yung matitira. So that will be our force. So next is normal and shear stress in the glue. Okay? So i-drawing lang natin, no? So kapag normal dun sa stress dun sa wood, so yung contact area lang din naman natin dito, no? Kapag diyan sa wood, so square 'yon. So ayan. Ito yung P natin. So ito yung wood natin. So this is 4 and this is 1. So yung area lang naman natin, yun na 'yon. Now, dito sa ating normal and shear stress in the glue, okay? So kapag limit lang siya sa 700 PSI. So kapag normal, so may tendency magfi-fail siya pag nag-exceed ng 700 PSI yung stress dun sa glue, no? And 450 PSI kapag dun sa shear stress naman. Okay? So para makuha natin 'yan, so i-drawing ko na lang ng 2D itong ating wood, no? So example, yan yung P natin, no? Yan. So yung direction ng P natin dito is pag ganun pala. Okay? So going upward. So meron tayong force P dyan. Force P. And yung sa glue natin, no? So naka-incline siya. So dito yung ito yung area ng wood natin, okay? This is area ng wood. And ito naman yung area ng ating glue. Okay? So at an angle of 30 degrees. 30 degrees sa horizontal. So for the normal, so i-drawing ko lang ulit. Hatiin natin. Ayan. So para mas maintindihan nyo. So meron tayong force P dito, no? And then, sabi niya dito, normal stress and shear stress dun sa glue. So ito yung sa glue natin, no? So kapag sabi natin kapag normal stress, so that will be perpendicular dun sa ating area, contact area. So yung magiging P normal natin is yung component lang nitong P natin. So remember yung statics nyo. So meron tayong component dito. Okay? Ayan. So ito yung magiging P normal natin. So kapag normal stress, contact area, perpendicular. Okay? So for the shear stress naman, so yun yung parallel dun sa contact area. So ito yung magiging shear stress natin. Okay? So that will be shear stress. So actually, yun lang yung magiging component ng ating force P. Tama? So at ang angle nito is 30 degrees. Tama? So para makuha natin yung force P in terms of normal and shearing. So ito yung area ng contact area natin. Ito yung contact area. So dun muna tayo sa normal stress. So that will be yung normal stress dun sa glue. So that is equal to force over area. So kung 30 degrees to class, no? Ito is 30 degrees din. Tama ba? Yan. So we can use yung makukuha natin yung P normal in terms of P. So yung stress sa glue natin, that will be P normal over yung area ng glue. Tama ba? Yan. So area ng glue. So that will be stress dun sa normal stress dun sa glue. So that will be equal to, so yung PN natin, so we can use the so sabi natin kapag ito right triangle, no? So we can use yung property ng triangle. So that will be, ito yung angle natin. So that will be cosine. Okay? So cosine PN, P is equal to PN cosine 30. So that, bakit sine? Kasi pag sine is equal to opposite over hypotenuse. So cosine pala yung gagamitin natin dito. Tama ba? Cosine is equal to yung sa katawan natin, adjacent over hypotenuse. Tama ba? So cosine adjacent over hypotenuse, so that will be Pn cosine 30 degrees. So that will be P cosine 30 degrees. So yun yung Pn natin. Tama po ba? Over yung area natin, area ng glue. So that will be yung area ng glue natin, so same lang din. Kung ito is yung area ng wood, so take note, yung area ng wood natin is 4 times 1, that will be 4 square inch. So yung area ng glue natin, so pwede rin natin gamitin yung cosine, tama? So that will be area ng, sige, sulat ko na lang dito. So that will be yung area ng glue natin is equal siya sa area ng wood over cosine 30 degrees. Tama ba? So sabi natin, ito area ng glue. So cosine 30 is equal to adjacent over hypotenuse. Tama? So parang ganito yan. Cosine 30 is equal to adjacent, that will be yung area ng wood natin, over hypotenuse, area ng glue. Okay? So therefore, yung area ng glue is equal to area ng wood over cosine 30. So I hope that is clear. Okay? So simulan natin yan. So therefore, yung area ng glue natin, that will be area ng wood over cosine 30 degrees. Tama? So therefore, yung burahin muna natin to. So therefore, yung cosine natin tataas doon. So yung normal stress natin actually is magiging P cosine squared 30 degrees over yung area ng wood. Naintindihan? So solving for stress for force P against dun sa normal stress dun sa glue, so that will be yung maximum natin 700 psi para sa normal stress ng glue. So that will be 700 is equal to P cosine squared 30 over yung area ng wood, that is 4 inch squared. So solving for P will be now, ito yung magiging P natin is equal to 3,733.33 pounds. Okay? So for the shearing stress naman, so for shearing stress, so parallel. Okay? So yung shearing stress natin is ito. So for PT, no? Yung shear stress natin, PT. So i-drawing ko lang ulit yung force triangle natin dito, okay? So yung force P natin. So ito yung force sa shearing force natin and yung normal force natin. So for normal force natin, so this is 30 degrees. So makukuha natin yung PT natin, so that will be equal to sine, opposite siya. Okay? So opposite over hypotenuse. So that will be sine, magiging P sine 30. Tama ba? Kasi sine 30 is equal to, so katawa, opposite, that will be shearing force over hypotenuse P. So So, manipulate nyo lang yung equation. So, shearing force is equal to P sine 30. Tama? Therefore, yung stress natin, shearing stress natin, dun sa glue, that will be equal to shearing force over yung area ng glue. So, that is equal to P sine 30 over yung area ng glue. So, yung area ng glue natin is equal to area ng wood over cosine 30. Tama? So, area wood over cosine 30. So, tataas ulit yung cosine natin doon. Tama? So, that will be yung shearing stress natin ng glue is equal to P sine 30 cosine 30 over yung area ng wood. Tama? Okay. Therefore, yung shearing stress natin, so given is 450 psi. So 450 psi is equal to, so P sine 30 cosine 30 over yung area ng wood, which is 4 square inch. Therefore, solving for P will now be 4,156.92 pounds. So, class, ano yung question sa atin? So, determine the largest axial force P that can be carried safely by the panel. Okay? So, meron tayong tatlong force P dito. So, makuha natin yung sa shearing stress, 4,156. So, summary lang natin. So, P dun sa normal stress ng wood, so that will be equal to 448 4480 pounds. And yung P natin dun sa normal stress sa glue, so that will be 3733. And P natin dun sa shear stress, shearing, that will be 4,156.92 pounds. So, ano yung maximum na kayang i-carry ng wood natin? Okay? So, yung maximum is always yung less or yung pinakamaliit dito sa tatlong force na nakuha natin. So, therefore, yung magiging answer natin will be P is equal to, so, maximum safe is equal to P 3,733 pounds. This will be our final answer. So, next problem. So, for the last problem, so this is a bearing, example of a bearing stress. So, the lap joint shown in figure A is fastened by 4 rivets of 3/4 inch diameter. Find the maximum load that can be applied if the working stress are 14 kSI for shear and 18 kSI for bearing in the plate. So, assume that the applied load is distributed evenly among the 4 rivets and neglect friction between the plates. Okay? So, meron tayong lap joint dito connected by riveted. Okay? So, kapag shearing stress is yung area nung rivet natin, no? Kapag bearing naman is yung dun sa hole and yung sa side nung ating yung side nung ating rivet. Okay? So, let's solve para mas madali nating maintindihan. So, for shear ng stress muna tayo, no? So, for shearing stress doon sa ating rivet, so that will be shear force is equal to uh, shear force equal to shearing stress times yung area. Okay? So parang force over area lang din yan. So shearing stress is equal to force, which is yung V. So denoted by V kapag shearing over yung area. Okay? So yung V natin dito is P over 4. Okay? Kasi yung force na nag-act along dito sa lap joint natin, which is yung P. So sabi niya dito, distributed yung ating applied load among dun sa 4 rivets. So magiging yung V natin actually dito will be equal to yung force P divided by 4 kasi distributed siya. Okay? Along dun sa 4 na rivet natin. Tama? So kapag shearing stress, so yung area, kung ito yung rivet natin, no, kung kukunin natin yung section doon, no, so same yan. So ito yung magiging area natin, which is ang diameter is 3/4 inch, no. So ito yung magiging area natin. Tama? So yung area nito will be pi over 4 3/4 inch squared. Tama? So sabi natin shearing force is equal to shearing stress times the area. So yung magiging shearing force natin, so yung force P will be P over 4 is equal to shearing stress. So ano yung maximum natin? So for the shear, that will be 14 KSI. So 14 KSI, i-convert natin sa PSI. So kilopounds per square inch yung KSI natin. So convert natin ng pounds. So kailangan natin i-multiply ng 1,000. So that will be 14 times 10 raised to 3. So magiging PSI na lang to. And yung area natin times the area, that will be pi over 4 3/4 square inch. So makukuha natin yung value ng P. Maximum value ng P for shearing stress, that will be equal to 24,700 pounds. Okay? So for the bearing stress naman, okay? For bearing, so ang maximum natin, ang working stress natin is 18 KSI. So that will be 18 times 10. 18 times 10 raised to 3. To 3 PSI. So ito yung working stress natin for bearing. Okay? So sabi natin kapag bearing, yung i-consider natin na area is yung hole, which is yung sa plate natin. So bearing force due to the contact force between the rivet and yung sa ating plate. Okay? So therefore yung sabi natin stress equal to force over area. So yung force natin will be P over 4 pa rin. Okay? Force nung bearing. So yung PB natin will be P over 4 pa rin. So force nung bearing. So that will be yung area natin, yung contact area natin. So kapag ito yung rivet natin, drawing natin. So if this is yung our rivet, no? So magkakaroon ng bearing stress. Yan, no? Pag may force dun, so nagkakaroon ng bearing stress yung contact area ng rivet at yung doon sa ating plate. Okay? So yung i-consider natin is yung thickness ng plate and yung diameter. Okay? So yung contact area natin will be diameter times thickness. Tama? So bearing force is equal to bearing stress times yung area. So yung bearing stress natin, maximum natin will be 18 KSI. So 18 times 10 raised to 3 magiging PSI yan. Times yung area natin will be yung diameter niya, which is yung 3/4 inch. Times yung thickness ng plate natin. So ano yung given na thickness ng plate natin? So 7/8 inch. Okay. So 7/8 inch. And yung PB natin, bearing force natin, that will be P/4 pa rin. So solving for P, for the bearing stress, so P will be 47,300 pounds. Okay? So, ano yung question sa atin, class? So, find the maximum load P that can be applied dun sa ating lap joint connection. So, yung maximum, always yung pag makakakuha tayo ng maraming P, so P for the shearing stress and P for the bearing stress force. So, yung maximum na load na kayang i-carry ng ating joint or lap joint connection ng plate is equal to, so yung max safe na P will be equal to 24,700 pounds. Okay. So this will be our final answer.